Hi, my name is Jasper Huang. I'm choosing question 1 and 4 for the final. So for question 1, we start out with a standard deviation of 4 and a mean of 64 units a day. To find the probability a worker produces more than 66 units, first we use this equation. Here we leave this part blank because it's our unknown, and the other represents a worker producing 66 units, and we want to know the probability is greater than 66 units, which explains the greater sign in the equation. The graph here also represents the area we are trying to find. When calculating, we have to look at the z-table for when z is equal to 1, which gives us a value of 0.8413, leaving us with a 0.1587 or 15.87% chance a randomly selected worker produces more than 66 units. For part B, when we choose 4 random workers, we have to change our equation to represent the multiple workers rather than 1. We then run the calculations and then look at our z-table to find the value, then solve. Once solving, that leaves us with a value of 0.0228 or a 2.28% chance that the sample mean productivity is over 66 units. For question 4, part A, we look at the z critical value for when alpha equals 0.05, which leaves us with a critical value of 1.645. Here, what we are trying to find is the shaded region on the graph, and this is where we will reject our claim. For part B, knowing our z critical value, we just have to find our actual z value in order to reject or accept our hypothesis. We use this test statistic to find our x bar in order to continue on to test for type 2 error. Here we compare with our alternative hypothesis that the average income is $310. By running the calculations, we are able to get negative 0.1512, and after we find this value, we go to our z-table to find the value for that, which is 0.4404, which equates to a 44% chance for type 2 error to occur.